I want to remind everyone it's coming up on time for the newsletter submissions. We need them by November 15th. So that's, 2 weeks from now. Bill Asich, ASHICH.1 is how you can email him. There he is, right there. Wave. Bill, wave. Okay. That's who you're emailing with your entries for the newsletter. And as you may remember from the past, we try to also have a visual to go with each person's entry. So please also send him a JPEG of whatever an appropriate visual would be to go with it. Okay, so getting into today's lecture, our lecturer is Professor Carey. She's from the Department of Earth Sciences. I forgot to ask you, when did you become Emeritus?
2021.
Good, okay. And she has been, I have a list of things here, elected fellow of the American Association for the Advancement of Sciences and of the Geological Society of America. Her research has appeared in high impact journals, including Geology, Nature, Journal of Geophysical Research, and Environmental Science and Technology, and another place that I can't pronounce because it's in Latin. Oh, come on.
Geochimica et Cosmochimica Acta.
How's that? and you told me what it's normally just called a
GCA.
GCA. That was much easier. Okay, Anna's the author of 61 articles and an editor of 3 special volumes. She's been the organizer of scientific sessions at national and international meetings. Her research has included the relationship between weathering and landscape evolution in the transport of solutes. Solutes? It's the right word.
Solutes.
Solutes. I was close. And sediments in small mountainous rivers, the role of urbanization and of agriculture on water quality, coastal aquifer dynamics, and permafrost hydrology, and the impact of climate change on water resources. Other research has involved the role of landslides in mobilizing carbon in watersheds in Guatemala and of extreme hydrological events in the control of weathering and solute transport in mountainous rivers of New Zealand, Taiwan, Panama, Spain, and Italy. Closer to home, Anne and her students have published results of their research on the Olentangy River and the Scioto River and the effect of the annual jump on water quality in Mirror Lake. Ongoing research includes studies of ice caves in Slovenia and NSF-supported studies of peat bog, hydrology, and geochemistry in Ireland. Her talk today is titled, "It's Not Always Raining in Ireland, Floods and Droughts on the Emerald Isle." Anne, welcome to the lecture series, and we look forward to hearing what you have to say today.
Thank you very much for that nice introduction, Audine. I'm going to talk about ongoing research in Ireland, and was there a couple of months ago, actually, sampling. So I will find my slides and share my screen. It's not always raining in Ireland. Now, this photo shows the results of a lot of rain in Ireland, where we've got boats floating in a picnic area. But I wanted to, before I got going, thank the colleagues without whom none of this would have been possible. And in particular to my student, Devin Smith, my husband, Barry Lyons, and our colleagues at the University of Galway, which until a few months ago was known as the National University of Ireland, Galway, but they've got a new name and a new logo. So images that convey to you the sort of weather that you probably think of when you think about Ireland. The mean average temperature is 8 or so degrees centigrade. And there's a lot of rain, with much more of it on the West Coast because the weather comes from the West and the Southwest. And the amount of the average annual rainfall is close to about twice as much as we see here in Columbus. So that's the average, but averages don't always tell the story. So William Butler Yeats was a denizen of Sligo in the north central Ireland. And I'm going to stop talking so you can read this. So everything comes from water. So you might be asking yourself this question: there's water everywhere, why go to Ireland to study it? But Ireland is a compact little country, but with a lot of rivers, and it gave us the opportunity to study hydrology and climate. And as a result of Barry Lyons' Fulbright Fellowship in Galway in 2018, we were there to sample the rivers and study the hydrology. And we lucked into a natural experiment on how things change with the weather. So let's look at this in a little more detail. Climate change is certainly a topic of conversation in lots of media. And for Ireland, they anticipate there'll be more annual precipitation, but that will come mostly through winter floods, as seen here in this photo, with summer droughts. And that's the part that's pretty foreign to Ireland these days. That climate change is likely to cause water stress. There's a growing population, which will add to that water stress. There's aging infrastructure. As water pipes age, that infrastructure may well lead to loss of water through those damage to the pipes. And then anthropogenic pressures, in addition to a growing population, there is more demand for water for agriculture and for manufacturing, and also as a medium to dilute and convey waste. So those are all concerns with changes in climate in Ireland. So if we look in particular at how droughts and floods will affect these, you can see on this list of consequences of droughts and floods, the first three are the same for droughts and for floods. But in addition, we may have water restrictions, fires, and infrastructure damage. And so all of those are problems for the human population. So as hydrologists, we have our own ways of evaluating these in particular of droughts, which I'll be talking about more than the floods. And so we look at the water itself, and we measure the stable isotopes of hydrogen and oxygen, the two atoms that make up the water molecule. And both of those chemical elements have multiple isotopes. Hydrogen has ordinary hydrogen, which is the 1H that you can see there first. And this hydrogen with two neutrons in it, with an extra neutron in it, is also known as deuterium. So the hydrogen 1 weighs 1, hydrogen 2 weighs 2, and then oxygen 16 and 18. 16 is the oxygen you learned about in chemistry in high school or college, and then heavier oxygen weighs 18. And none of these is radioactive. So their chemistries are identical, whether it's oxygen 16 or 18, say. But the physics are different because we've got a 12% increase in mass for oxygen 18. And those different weights affect how the water, the hydrogen and the oxygen, are lost from the water in the water molecules. So because a molecule of water with oxygen 16 in it is lighter, it can evaporate faster, effectively enriching the water in the water body with the heavier molecule that contains oxygen 18. And so that's in the third bullet point. As extensive evaporation occurs, there's an increase in what we call the delta 18O increases. So we look at the ratio of these molecules and use that as our tool to evaluate drought. If there's been a lot of evaporation, we're going to have heavier or enriched water. And we measure this lots of places. I actually collect water in our backyard and have been studying it for nearly a decade and what's going on with the Columbus water. So, as I said earlier on, we're mostly going to talk about droughts. And there are four primary types of drought. The meteorological drought, which is a deficit of rainfall, and those typically last for 1 to 3 months. Agricultural drought is similar, except that they typically last as much as 6 months, and these are characterized by insufficient soil moisture, and that reduction in soil moisture leads to loss of crops. Hydrological droughts, which are the ones that you mostly hear about on the national news, say in California or New Mexico or Arizona, is lack of water in the hydrological system. So it's not just rainfall and soil moisture, but also low water levels in rivers and lakes. And actually, we're having that these days in the Mississippi River system. And then socioeconomic droughts are a little bit harder to quantify, but they're characterized for the times when water demand exceeds the supply. So it's definitely human driven. So if we're looking at drought in Ireland, we're mostly looking at current day issues, but this figure here is from a paper from the Journal of Archaeological Science, in which the authors compiled information from annals of of Ireland, and they did not read the original annals that were created in the early medieval times, but they looked at compilations that were created in the 15th to 17th century by monks who looked at the original annals. So it's not quite a primary source, but close. And what they found mostly in Central and Northern Ireland, that there were a variety of happenings, weather happenings, snowfall, storms, and drought that they could infer from descriptions of storms themselves, loss of crops, or loss of animals from snowfall in particular, killing the animals. And you can see that it's not a regular cycle, but even 1,200 years ago, there was time in Ireland when there were droughts and all kinds of storms. So these droughts and floods that we're seeing today in Ireland are not unprecedented. So with all of that as introduction, what I want to do is give you an outline of the science that we'll be talking about today. The study area is the rivers of Ireland. I'll talk a little bit about the climate and then talk about the kind of weather that there was occurring in 2018 and in 2020, show you a few results and make a few conclusions. So this photograph here is of the River Moy flowing through the city of Ballina in County Mayo, which is where we always said my grandfather was from. Since I've been to Ireland many times now, every genealogist I talked to said, oh no, all the Careys came from Belmullet, which is the far northwestern corner of County Mayo. And it must have been so desolate when my grandfather left it 100 years ago. But this is a beautiful downtown shot of County Mayo, and it's how I think of Ireland. So let's get on and talk about the study area and what we sampled. So in 2018, Barry and I collected many river samples from the largest flow rivers in Ireland. And over the course of 4 major campaigns from March to August of 2018, we drove 4,500 kilometers, which is a long way to drive on the little island of Ireland. And since then, we've been back multiple times to collect samples. So I wanted to point out a few locations here that I'll be talking about. The River Corrib flows through County Galway, and I have multiple pictures of it in Galway City. The Shannon River, which is our major study river, starts up here in the north central part of the Republic of Ireland, and it comes out of the carbonate bedrock here at Shannon Pot, flows down through Dowra, Drumshambo, and here to Lanesborough, to Athlone, Shannon Bridge, Banagher, and Portumna, and Ballinav, Tipperary. So that is the Shannon River, which is one of the largest rivers in Europe, and it's by far the biggest river in Ireland. Another place I have some data from is the River Suir. I have some photographs of the Feel. This is County Carey down here. And the River Bann is in Northern Ireland, but we have a colleague there who collects samples for us. And here's the River Moy, and that dot is Ballina that I showed you. So those are some of the places that you'll hear about in a little bit more detail as we go on. But before I do that, I wanted to talk about the climate, as my outline said. So this figure shows the mean monthly temperatures for the 30 years from 1981 to 2010. And I have these here to compare to the conditions that we encountered during 2018. And so in 2018, the winter, which was actually begun in December of 17, was cold and snowy, and there were heavy snowfalls that they called the Beast from the East in early March. And this spring was later recognized as the wettest spring since 1964. And then around in May, things started to warm up, and it got warm and it got sunny, and it went into the driest June. This is June, where the average annual monthly temperature is 13.6 degrees, and the average temperature for June of 2018 was 17 degrees C. So quite a bit above the long-term average. So it was certainly an unusual summer. This figure has a lot of information on it, but it's very informative. So we have on here 3 different ways of looking at drought or flood. The standardized precipitation index is a quantitative measure, but it also can be characterized by 7 groups of precipitation indices. So January of 2018 was severely wet, and that's mostly snow. And then as we go into February and March, it got quite a bit drier, and it got severely dry to extremely dry. April was normal. And then you go into May, and it got severely dry, and June was extremely dry, and July was extremely dry, and then in August it got a little bit wet again. So these wet and dryness standardized precipitation can also be described by the percent of normal index, which the bright blue is non-drought and the dark red is extreme drought. And as you went from January to August in 2018, January was non-drought. There were places in the southeast part of the country that had drought, but April was still quite wet. Then in May, it began to dry out, and in June, over half of the country was in extreme drought. And the vegetation anomalies in the bottom row are based on MODIS remote sensing images that showed, in the January and February, there was snow cover. We got to March and that went away, and the vegetation anomalies were close to normal, and then dried out again as the year got drier and drier. So this is what March looked like. So March, here's March, where a significant part of the country was non-drought or normal. And this is along the Shannon River in March, and this was what March felt like. Very wet and cold, and I wouldn't get out of the car. So Barry did the sampling. And if we still in May, it was pretty chilly. And this is the Corrib River in downtown city of Galway. The river's flowing high, and it was chilly. So the weather was cold and not bad, but still pretty chilly. And then in June, this shows the precipitation anomalies globally, with a circle around Ireland showing you that it had a severe meteorological drought, meaning too little precipitation. And these and conditions led to water restrictions of a kind that they had never seen before, and health concerns from the high temperatures, and some socioeconomic impact for manufacturing. Depending upon. And then this is what late June looked like in Galway City. And this is the kind of weather we'd have in Columbus in June. But this was 4 or 5 degrees C higher than average. And the residents of Galway were hot. They didn't like it. I thought it was great, but it was untypical. So here is a figure showing some of the data that we have both collected and analyzed from the Office of Public Works in Ireland. And there's a lot of information on here. So the Sur River is I didn't point that one out, I'm sorry, in the east part of the country. So here in this graph, we have in the light blue lines, the precipitation, and the precipitation goes from 0 to 100 milliliters on the right-hand side. And then the river discharge is in cubic meters per second, and the discharge is shown by the black line at the bottom. And you can see the correspondence of it rains, the river discharge goes up. It rains, and the river discharge goes up. And that went on throughout, well, that's how it happens. But we sampled in May during this first pink bar section, and then in August, after a summer of almost no rain, we went back and sampled again. The other things that are shown here on this graph are the 75, 90, and 99% flows. And these are determined to be the flow that 75% of the time, 90 or 99% of the time, the river is flowing higher than that. And you can see in July and August and even into September, the Sur River, which is a tributary of the Shannon, was flowing lower than 99% of the time that it does. So very significant reduction in input via rain and flow in the river. So this figure here is national river flow estimates from July, for a week in July. And the red dots mean the river at the gauging station was at or below the 95 percentile flow. And that was 115 of the stations analyzed. The yellow dots are above the 95th percentile flow, and the green dots are above the 95 percentile flow. This is a useful map because it shows you where the rivers are relative to the city of Galway, Dublin, Kilkenny. So this figure was created during a time of sustained dry weather, a definite meteorological drought, and more than half of the gauges were below the 95th percentile flow. And this is an important number because Ireland's capacity for wastewater management is based on the 95th percentile flow statistic. And when the river gets below that very low flow, there's no discharge allowed into the river. And another big issue that happened is Dublin rationed water because their water comes out of the Liffey River, which is not one of the big ones, but they do have a couple of reservoirs. But because of these very low flows, they rationed water. In a little more detail, this shows the soil moisture deficit for the year of 2018 at the Dublin airport. And as the caption from the Falzoy et al. Paper says, the soils were twice as dry as normal in July. And you can see that for most of the year, except for a brief time in April and May, the soil moisture deficit was significant. So we have multiple ways of looking at this drought in Ireland. So what I want to do now is talk about some of the quantitative data and the isotope data that we have. So this figure doesn't have any river names on it, but the evaporation fraction, or the amount of water that was evaporated, ranged in May, what we calculated typically as only a few percent. But if we go to August, using the isotopes, we saw that as much as 9% of the river water was evaporated, and in Galway, and this one is the Shannon River. So, tremendous amount of evaporation. So this is what Galway City looked like in August. This is actually right behind where I was standing in that picture from May. And if you look in the center of the picture, you can see some dark areas along the banks that are normally covered with water, and they have algae on them that need that water to grow. So this and these banks in the river itself are rarely exposed. And here's a figure from down in the southwest of the country in County Carey. And it's pretty, you can see here on some of these bridge posts areas that are normally wet. There's a big bank in the middle of the river that's rarely above water. And here's berry sampling. So that's how low the flows were in the river in August. And then in winter 2020, so a year and a half later, Ireland had one of its wettest winter months on record. We were there in 2018 and we thought that early that winter was pretty cold and wet, but 2020 was quite a bit wetter. There was rain on, it was a leap year, so there were 29 days, and it rained on 27 of them. And there was, throughout Europe, there were precipitation anomalies, but if you can see the details of the color that Ireland in the lower part of that circle had some of the biggest anomalies of all of Europe. So here is a figure or a photo of the River Shannon showing the results of those floods with very high river flows and flooding. So this is a boat dock. It's normally the handrails for walking down. It's usually subaerial, not subaqueous. So we'll talk a little bit more about the River Shannon. And this is a photo of Shannon Pot, which is a sinkhole in the carbonate bedrock where the Shannon has its headwaters. So this is quite similar to figure that I showed you before with the evaporation fraction. And so Dublin, which is over on the east coast of Ireland, gets 85% of its water from the River Liffey. And that's in a region of not the greatest evaporation, but it's a significant amount of evaporation. And the city of Dublin has proposed that it build a pipeline to bring water from the lower Shannon up to the city of Dublin, where currently about 25% of the country's population lives, but with the growth anticipated in Dublin, it's going to be much bigger. So the way that we look at this is that we look at the contours of that delta oxygen 18, the heavy oxygen, and this is the per mil, the delta oxygen 18. And I didn't give you the definition of it just to simplify things a bit, but we've got the redder the color, the much more oxygen 18 in the molecule. And from May to August, there's been progressively more and more loss of the lighter water molecules containing oxygen 16, and that's reflected in the measurements of the oxygen 18 that we make. These data were part of Devon Smith's dissertation and a paper that she has in review right now. So this is what the stable isotopes look like. Since about the early 1960s, the stable isotopes of water have been a tool for all kinds of geochemical studies. I mean, for us, in particular for hydrology, and the global meteoric water line, the solid black line on this figure, was first described in the early 1960s by Harmon Craig by looking at the results of analyses of rainfall from all over the world. And then by looking at local waters, you can, what we've seen here, the dashed line is the local meteoric water line for Ireland. And what I do here in Columbus is make a central Ohio meteoric water line with the rainfall that we've collected on campus, in our backyard, and at a few students' homes over the years. So if you have enough data, your plots of individual waters of deuterium on the y-axis versus oxygen 18 on the x-axis plot near the global or the local meteoric water line. And then when the water evaporates, you lose more of the light molecules. And so you have more of the points plotting below the meteoric water lines. And this heavy black arrow here shows the trend of when you have evaporation, of how the points fall off the line. And the green points, mostly hidden here, are from March, when we didn't, 18, when we didn't expect to have had much evaporation, and they fall right near both meteoric water lines. Then the yellow points are the Shannon River in June, and the red ones, the Shannon River in August, and they're falling down off the line more and more. And then the purple ones from March of 2020, when we're back to normal to flood conditions, the Shannon River waters are back on the meteoric water lines. So these isotope data have been our primary tool in making a lot of those graphs that we showed, like this one, which is the, I've shown again, but I wanted to talk about the water supply project that the city of Dublin has proposed. Now, in the arid US, mostly in the Southwest and far West, interbasin water transfers are dirty words. I don't know that it is in Ireland, and I don't want to deal with those politics, but what Dublin has proposed is to divert 2% of the Shannon River's flow through a pipeline that back northeast up to the city of Dublin. And this project has been disputed, and I will let some of my colleagues talk about that more, but it's the need for the project is based on the anticipated population and economic growth, but the project isn't planned to take place for another 20 years, so they have lots of time to talk about it still. We can see that it's coming from a part of the Shannon where there is a significant amount of evaporation going on. So that's about the end of the data. I hope I've convinced you that the stable isotopes are a very useful tool that is that we can use to, or are reflective of the drought in the Irish rivers in 2018, and how the isotope data show how quickly the systems can return to normal after a wet year. I didn't talk about the lakes or the lochs in particular, but something that's going on with them along the Shannon is that they homogenize the signal both geochemically and hydrologically. So I'm really sorry that we can't be together and have a beer with this talk about Ireland, but I still want to say Sláinte to all of you, and to thank both the people who worked on this together and the funding agencies from the National Science Foundation that have provided money both for instruments and to conduct the science. And this is Devon Smith sampling the Shannon River. And none of it would have been possible without her. So thank you, Devon. She got her PhD in the shot in August, and we're all very proud of her. So thank you all for your attention. Hope I haven't blabbed on too long.
And thank you very much. Enjoyed it. I'm looking for questions that someone might have. I have the chat open, and so far you're getting many thanks, Anne, but I haven't seen any questions yet. Questions. Morris, do you have one? You can just turn on your microphone too.
Okay, thank you. You mentioned in a drought, I guess it was in particular about Dublin, that sometimes the wastewater is not discharged. Then they don't let it discharge. What happens to it? What's done with it?
They have to, I think that those are mostly industrial discharges rather than, I mean, they can discharge it into the ocean, or industrial discharges that would go into the rivers just have to be stored until they, till the river flows are higher again. Okay. And actually Devon, who's on here, might have a little bit more to say because she's looked into it more than I, but so either they end up with very high quality, low quality water, or they just have to hold it. Or quit manufacturing until they can discharge again.
Okay, thank you.
And how about another question from anyone? I mean, everything was so clear, Anne, in what you presented. I'm not sure that it gave
you flatter me.
Many questions.
I will ask a question since it wasn't all clear to me. This is Kay Hubner. I missed the beginning, so maybe that's why it's not so clear. I'm a new member, but I wondered if it's very expensive to do those isotope studies, and if it's something that would be viable for people to do many studies for many sources of water.
The answer is, until recently, yes, it was very expensive because those analyses had to be done with a mass spectrometer and it could cost, well, for water, we used to pay about $25 a sample to have them analyzed at a facility at the University of Colorado. About 20 years ago, a new kind of technology for measuring, for separating the isotopes became available, a new kind of spectrometer. And so we run them routinely, probably for a couple dollars a sample. The other part that's different in terms of cost is that the mass spectrometer, to purchase one would be $500,000 in rough numbers. And these cavity ring down spectrometers that we have two of in our lab now cost about $80,000 each. So it's a factor of 4 or 5 times less expensive to acquire the instrument. And the acknowledgments that I gave that included a couple of NSF grants, those purchased the instruments that we have in our lab in Mendenhall Laboratory. So you were right, it used to be expensive and now it's affordable. And so it enables us to do lots and lots of samples. So we have a better picture of what's going on with lots and lots of samples.
But
Does that answer the question?
yes, it does. But there's another part to the question, and that is how useful is it? I know that I should have understood a lot more, but would this help people in California, for example, who are having major drought problems, and in Colorado, and what does it tell you?
Well, it tells other things in addition to the fact that you're having a drought, which you probably could go outside and say, well, we're having a drought because it hasn't rained, or we're having, too wet conditions because it rained on 27 out of 29 days there. You can also use it to look at the source of the water, where it's not just, I had much more complicated diagrams about stable isotope hydrology that I took out to simplify things, but you can, the isotope signature changes as rainfall comes off the ocean, and in California goes up and over the mountains. And so you have a fairly predictable evolution of the isotopic signature as a result of those changes. So what we do, one of the ways we've used the rain here is to look at the analyses of rain here in Columbus is to look at where our rainfall is coming from. And so Devin has a paper published from, actually it was the first data she analyzed here, looking at whether our rain is coming down from Canada or up from the Gulf of Mexico.
Okay, that's interesting, really. Thank you. Thank you very much.
You're welcome.
My name is Marguerite, and I had a question about the differences between 016 and 018 and whether it's possible to, what would you say, convert, say, a dense area of 018 along a coastline near a drought area into 16 so that the 16 would evaporate and then move west, or in this case, east, if we're talking about our West Coast, to create rainfall. Can is it easy to convert 18 to 16?
No, they don't get converted. They could, a 16 and an 18 could exchange in a water molecule. But what we're mostly I've been talking about is how the difference in weights affects the physics of the behavior.
Okay.
So we're not having a conversion of one to the other. It's not like with a radioactive isotope that does change from one element to another.
Thank you. Thank you much.
And I was wondering if typically there's both 16 and 18 oxygen. When there's a lot of evaporation and there's more 18 oxygen, what's the effect on the fish and the other and plant life in these rivers? I know, the river's level has gone down, but can they use oxygen either of those densities equally?
I'm getting out of my comfort zone here. I would say yes. I think they don't notice. I do know for certain that plants preferentially take up carbon 12 over carbon 13 because it's lighter, smaller, easier to get across their cell walls. But there are enough people I see or were here who might say more about that. I'm not a biologist, but
I was just wondering if it came up in your studies that someone would start talking about that. Any effect?
No, you're the first. Have to see if there's any literature on that. Thank you, Arlene.
Okay, some more questions. Well, Anne, we thank you very much for your presentation today, and applause, everyone. And we hope to see everyone in December at our next lecture. And I meant to have it. Jason, help. I don't have the list in front of me, so I don't remember what our December lecture is. I'm very sorry about that. As I said in the beginning, I kind of have a cold and I'm not making perfect sense today. Otherwise, anything from anyone? Remember about the newsletter being due by the 15th of November. Otherwise, we'll see you at the beginning of December for our December lecture. Have a great evening.